Hello, today we're going to be doing a physics question and it's on standing waves. So for an open pipe, the frequency of the first harmonic is f and its wavelength is lambda. For a given harmonic of the same pipe, the ranges of motion of the particle in the pipe are shown below. And we're given three statements and we're trying to figure out which are true. So for me, the first thing I would do is because sound waves are longitudinal, and that confuses me a bit more. For me, I would like to see them as transverse waves, so I'm just gonna draw them out. Okay. So it looks something like this. And I would compare them with pipes that have two closed ends to determine which harmonic this is in. So this is the first harmonic. Let's say the left end is the number of harmonic, and the right end is the number of nodes. So, okay. And therefore, this is the first harmonic, and there are 0 nodes in the center in this area. So there's 0. And for the second, it's going to look something like this. So this is the second harmonic, and there's 1 node right here. For the third one, it's the third harmonic, and it's going to look something like this. And there are 2 nodes. So, etc., etc. Third, fourth, fifth node, fifth harmonic. And to figure out which harmonic this is, I just need to reverse it. So I need to count how many antinodes there are because the two ends are antinodes. And we can see that there's 1 antinode right here. And if there's 1 antinode, it is the second harmonic. So we know that n equals 2. And this formula is in the data booklet, but for 2 closed ends or 2 open ends, lambda is 2L over n. And this is a ratio question sort of, so we need to compare the first harmonic and the second harmonic. So, and it wants the frequency mentioned as well, but let's just do wavelength first. So lambda 1 is the first harmonic, lambda 2 is the second harmonic, so 2L over n, and n is just a number of harmonic, and it's just 1 for the first one, so it's just 2L. Whereas for the second harmonic, n is 2, so 2L over 2 is just L. And we can see that the wavelength for the first harmonic is 2 times the second harmonic, so 2 is wrong because it's not wavelength over 4, it's wavelength over 2. And the wavelength is less than lambda, that is right because it's 2. And for the first one, frequency is 2f. So now let's replace lambda with, because we know v equals f lambda, so lambda is v over frequency. So, okay. And now let's compare the harmonics. Okay, so replacing lambda with v over f is this. And we already know that first harmonic is 2L and the second is just L. And now we can isolate for F1 and F2. So F1 over, so we're just flipping them right now. Okay, and F1 is V over 2L. F2 is V over L. And for standing waves in pipes or strings or anything, the speed of the wave is constant because that's how standing waves work. So let's just ignore V. And we can clearly see that the frequency for the first harmonic is going to be smaller than the second because it's divided by 2, whereas this one is by 1. And this also means that F2 is 2 times the frequency of the first harmonic. Okay, and let's see if this is right. And yeah, it is. Okay. This means 1 and 3 are correct, which means B is the answer. Thank you.